Our next application is drawn from the sphere of genetics. I always find, when tackling a new subject, that the history, the context, is informative, frequently illuminating. And, if you'll indulge me, I will begin with a preamble taking you back in time to the pivotal moment when the science took off. This was in the year 1859, and the book in question, of course, was Charles Darwin's The Origin of Species by Means of Natural Selection. Now, this was a revolutionary volume, an incendiary volume, an epochal volume. To understand why this book had such a large impact, was so divisive early on, we need to understand the context of that time. Now, through recorded history, our traditions, our religious customs had held that events in human history were shaped cataclysmically, from the formation of the earth to the origin of species, that these happened in relatively short periods of time by violent, cataclysmic things like floods, bolts of lightning. Now, around the early part of the 19th century, these questions were drawn into some doubt among a few thinkers. And this was brought to a head by the publication in 1830 of the first volume of 3 of the geologist Sir Charles Lyle, a Scottish geologist, who published a book on the principles of geology. Lyle held that far from the earth being created by cataclysmic events like floods and so forth, that in fact the evidence on the ground suggested that the formation was much more gradual, much more by a long period of accretion of small events. This is a position we now call Uniformitarianism. And Lyell's idea was that things like erosion, wind, water, over very long time spans, ultimately resulted in the massive changes on the Earth's topography we see today, the Grand Canyon, Mount Everest, and so forth. Now, this was quite contrary to our common understanding, our tradition of formation. This volume had been extant for about 20 years when a young Charles Darwin went out on a voyage around the world on HMS Beagle, and the captain of the ship gave him Lyell's first volume. To put it mildly, Darwin was enraptured by the glorious sweep of the ideas that Lyle laid forth. Here are a couple of iconic images of Darwin. One taken in 1816 at age 7. You can see that there's a budding botanist, a naturalist all today on your scene, holding out a potted plant. The second image, perhaps more familiar to students and readers, is that of a brooding Darwin. This was about 9 years after the publication of Origin of Species. You could see the distant look in his eyes, a measure of sadness, because the theories he promulgated were highly controversial, caused no end of dissent, perhaps peering past what is the purview of mortal men. Now, what did Darwin postulate? In a nutshell, Darwin postulated a uniformitarian theory for the propagation of species. And like Lyle, he suggested a mechanism where species propagate by passing on hereditary information from a parental generation to a filial generation and so forth, that in so doing they compete with other species. The winners survive, the losers fade out. Qualities that are found to be useful are preserved, and qualities that are found to be detrimental or harmful eventually vanish. And he postulated all of this based upon empirical evidence that he gathered on 2 long sea voyages. Now, the ideas immediately had two strong opposing points. First, Darwinian evolution required a very long time scale, and this runs promptly against religious tradition, for instance, which, depending on the part of the world one is in, postulates that the origins of the world are from a few thousand years to maybe tens of thousands of years and sometimes 100,000 years. Much too little for Darwinian evolution. The second is that Darwin did not have a clue as to what this hereditary mechanism might be. Proposing a theory like this in the face of tradition, in the face of opposition, would require great chutzpah, great cheekiness at minimum. But Darwin proposed it. Now, the first of the objections that the theory required a very long time span. Originally, it had a setback. Thermodynamic calculations by Lord Kelvin, based on assuming a cooling world, a cooling Earth, suggested that the Earth could not possibly be more than about 100,000 years, and later revisions to his calculations led Lord Kelvin to conclude that perhaps the Earth was not as old as 50,000 years. Much too little for the kind of time span that Darwin needed. This was eventually overturned at the turn of the century by the discovery of radioactive emission by Rutherford. A brand new energy source had now been discovered, and now modern estimates put the age of the Earth at about 4.5 billion years, more than ample time for the kind of evolution that Darwin had in mind. The second objection, that the mechanism was obscure, needed the advances in looking at biological objects under a microscope at very high magnification to start understanding the biochemistry of these objects, required the understanding of that we ultimately now call a genetic structure for life. Of course, today we understand that genes are the method by which hereditary characteristics are passed on from generation to generation. The entire set of features that describes a living organism. For instance, in Homo sapiens, the eye color, the shape of the face, skin color, the opposing thumb, and so on and so forth, are all encoded in the human genome. So now let's take a step back and take a look at this mechanism.